Hello everyone, my name is Prashant and today I'm going to talk about debugging kernel issue. This is actually a three-part series in which in the first part which I'm going to present it today, I talk about mainly some of the known issues, the difference between a crash and a hung, and like I mentioned some of the known issue which we have faced in our day-to-day life, like for example your kernel spin lock issues, your NMI watchdog issue, the MC log issue. So all these issues I'm going to cover in this series, in this first part of the series. In the second part, I'm going to demonstrate about how to configure kdump over the various sources like the local dump and over the NFS or over the SH. And in the last part, once the kdump is configured and whenever the system panic, we can generate a vmcore out of it and how to read that vmcore. So it's basically a three-part series in which we can debug about all those kernel issues and means how to debug all those kernel issues. And not only we can debug on the kernel crash and hung, but with the help of a kdump and with we having a vmcore with it, we can also debug like any of the performance issue. Okay, so let's get started. So whenever we talk about kernel debugging, the first things which generally comes in our mind is debugging the kernel crash or hung. So these are the things which generally comes in our mind. So uh, because that is the first things. So like first of all we need to think about like most of the people which I have seen is like according to them like the crash and a hung are both are the same but they are fundamentally different, and some people say it is hung but crash or a hang or hung, whatever you will try to say it or whatever you would like to say it. So they both are fundamentally different. So like whenever we talk about a hang or a hung, it's often temporary in nature. Might be possibly it will be caused due to any time consuming operation, and it's is like difficult to debug as compared to your crash because there is no oops message which is displayed in your screen. It might be caused because of any inefficient algorithm, and it might be because it can be as complicated as deadlocks. So like I mentioned, it is difficult to debug because there is no oops message which is displayed on the screen, which is happen in the case of a in a case of your crash. And in that case you can at least do the backtrace and try to find out the function which is responsible for crash or whatever the function which is executing at the particular time during the time of your crash. So to debug any of the hung issue, generally it is recommended to configure a kdump along with your system request key or sysrq key, which I'm going to demonstrate in the second video. Also the watchdog timer is also helpful, which I am going to demonstrate in the next couple of slides. The second thing is crash, which is different as compared to your hang or hung, which is generally instantaneous in nature. And generally, you will see a oops message which is displayed on the screen, or in your ILO or in your bad log message if you are lucky, and it's followed by your reboot. So generally, the crash will happen because of any of the programming error, any or defective piece of your hardware, or might be because of any of the unsupported operation. So generally whenever the oops message is displayed, it reports some kind of a bug or some kind of any kind of a hardware problem. So just one of the misconceptions that people have, like whenever they see the oops message in the well log message on the screen, oops message is not always a fatal. Your system might be continuing to operate with some kind of a degraded performance, but still your system is up and running. And like I mentioned earlier, like the oops message is really helpful in order to know what exactly kernel will executing at the point of the kernel crash. Okay, so there is one website called kerneloops.org where you can see like a lots of oops message which has been according to the version of kernel that is a really helpful. Okay. Now the last thing which I'm going to discuss except for your kernel crash and hang is like application can rarely make your entire system crash or hang because application cannot directly talk to a kernel. They talk to a kernel via your system call. So means applications are generally isolated in such a way that the system and process will not be affected. Okay, but but still we can we can contradict with this way, because sometimes you have run your application and your system become unresponsive. So the reason for that, because like I mentioned, that your system makes a your application make a system call, which is invoked by your application, may cause some operation in kernel space that will eventually cause a crash or a hang. So it's a system call which is making, that will cause some kind of a hung or a crash, but your application cannot directly uh, cause a hung or a crash. Okay, so here I am going to discuss some of the general uh, software crash or a hung, or what are the different kind of error which we have seen in our day-to-day life. So first thing is your soft lockup error. I think most of the people who are watching this video have seen this error somehow, means in your any of your production or your non-production server, which is like you will see this kernel bug soft lockup, your this CPU, any number of CPU 0 or 1 or whatever, stuck for 10 seconds, and like what are the process which has been stuck at the end. I think I missed the process name, but at the end you will see the process name, or your process stuck for this much amount of a second. So what is exactly a soft lockup? So soft lockup are basically a situation in your kernel subsystem that your kernel subsystem has not given a chance to perform its job for more than a x number of seconds. Or in other word, I can say it is kind of a bug that causes your kernel to loop in kernel mode for more than x number of seconds without giving other tasks a chance to run. Okay, so generally means whenever this soft lockup occurs, you will see a stack trace upon detection, and system will stay locked up. So system will not perform any kind of a task. So why exactly this soft lockup occur? The most probable cause of this soft lockup is the defect in your kernel. Okay, so whenever you got the stack trace of whatever is executing, for example this, and after got a stack trace, uh, the most probable thing you can do is to look for any of the bugzilla which has been associated with that particular soft lockup. It might be because of your hardware issue and due to extremely high workload in your system. In that case, you can see you can use SAR to find out what is exactly, or simply the W command to see what is exactly the current workload in your system. So the other thing you can do whenever this soft lockup is happening and you are not able to figure it out, like why this soft lockup is happening, you can configure one of the parameter along with your kdump, and you can make your system crash at the time of soft lockup. Soft. So generally it has been disabled, but if your system is seeing this kind of error on a frequent basis and you are not able to determine like what exactly you can do, just enable this parameter, like make it 1. And if the kdump is configured, whenever your system is having this kind of a stack trace, the system will generate vmcore, and you can easily, which can help you to debug out like what exactly the cause of the issue. Okay. If you look at the first line, it says that kernel bug soft lockup CPU 0 stuck for this much amount of seconds. So this has generally been configurable with the help of this parameter. Like in case of a rel 5, this parameter called kernel.soft lockup underscore thresh equal to 10. You can configure it. In case of your rel 6, it has been changed to watchdog underscore thresh. Watchdog. This one is equal to 60 seconds. So like I mentioned, if your means kernel has not been given a chance to perform its job for more than this, you can see this kind of a trace in your console or in your Verilog messages. So you can even configure this parameter to as low as like 10 or 1, but this has been not been recommended to change this parameter. Okay, now let's look at this error. So this is one of the error which I think seen by most of the people, and this has been introduced in case of a rel 5.5. So if you run psaux and grep for something called hung, so you will see one of the kernel thread called k hung task d, and currently it is in a sleeping state. So starting, like I mentioned, starting from rel 5.5 or this kernel version 2.6.18.194, the khung task d thread is introduced or added in the kernel, and it provides the ability to detect a task which has been in uninterruptible state for more than 120 seconds. Okay, so if there is any task which has been in the uninterruptible state or in the D state for more than 120 seconds, this thread is going to detect those kind of a task, and you will see these kind of a message like your this particular task, or after that the process name along with the PID is blocked for more than 120 seconds. Even this is configurable. So if you go here and look for this is 120 second. Kernel hung task timeout second equal to 120. You can even change it to 10 second or whatever, or if you make it to 0, it can disable it. So if you look at the second line, it will saying echo this to this much, disable this message. Okay, so if you don't want to see this message, generally based on my experience, I see that there's some of the developer who has created their process or develop their code, like their process need to go into some kind of a sleep or in an uninterruptible state so that it can wait for IO. So in that case, we can disable it, but generally it is not been recommended. Okay. So generally when you see this kind of a message, which it suggests that system is experiencing some kind of disk or memory congestion, and the given process currently starved for resources, available resources, which might be a CPU or IO or whatever it is, or memory. Okay. It might not always indicate a CS problem, like I mentioned. If some of the developers who write their code in such a way that the system will go into some kind of uninterruptible sleep, then in that case you can even disable it. Okay. And whenever you see this kind of a message in well log message, only the first 10 instances is being reported. So this is the way this has been coded so that it will prevent your system from being flooded with this kind of a messages. Okay. So if you cannot see messages after after 10 messages, you still don't means if you didn't see any of these kind of messages in your well log message, that doesn't mean that the issue is resolved. Your system is still being stuck, but it is not being reported by khung task because this is the way it is configured. So like I mentioned earlier, in a case of this your soft lockup, if you see this message continuously on your screen, you can even make this kernel hung task pen equal to 1, that is enable this parameter. And if your system again experiencing this kind of a issue, this will create a vmcore whenever your system again face this kind of a issue. So after that, with the help of vmcore, you can debug like what exactly the issue. Okay, so the first two things which I have told you is regarding the soft lockup, which is like or at your software level, whatever the general kernel issues you are seeing at the software level. There is one more called out of memory error. Like I'm just going to speak about some of the general issue which we are facing in our day-to-day life or in our day-to-day like activities, whatever we are performing at the system admin level. The third error is out of memory error, in which your system is run out of memory and it start killing process based on the padness value. I'm not covering that topic in this video because for that I already created a one video that is called out of memory error, in which I clearly explain how this badness value is calculated, what are the parameters which has been considered to create make this value, all the underscore score parameter, underscore addition parameter to tune this value. So I'm not going to cover it in this video. Okay. Now let's look at some of the hardware level, like whatever the error you are seeing from kernel side at the hardware level. So starting from your x86 architecture, okay, your CPU reports error detected by the CPU, and there's something called machine check event. So they may be because of the data corruption happen at your CPU cache or main memory by an integrated memory controller. So like the major cause of all these errors is because of your broken hardware, any sort of a cooling problem, and any sort of a unstable power supply. So like I said, now we have jumped to the hardware level. So means this is a feature introduced in x86 architecture where we can detect hardware error. So you can see these kind of a machine check event like machine check event MC hardware error. This is not a software problem. Please contact your hardware vendor. So generally you see this message in where log messages, or there is a daemon which has been introduced called MC log, which is just a user space translator for reported machine check event by the kernel. So like what kernel will do when they see this kind of events is to start killing those processes. And MC log, like I said, it's kind of a translator. So it decode the error and record them inside one of the special file called where log messages. Okay, so whenever you see this kind of a error, it most of the cases it means it because of the hardware problem. Okay, so you need to contact your hardware vendor or just run the hardware diagnostic utility which is provided by your hardware vendor. And I think Reddit provides a utility called memtest through which you can test your RAM and CPU. I'm not sure about CPU, but you can generally and definitely test your memory. And in some of the cases, updating your BIOS will fix some of the false MCE error. So let's look at that. I'm not sure this has been installed or not on my system. Okay, so not installed. So you just need to install this RPM called MC log. Okay, and whenever it sees any kind of that hardware issue, it will just decode it and print inside your uh, verilog verilog MC log this error. MC log error, hardware error. This is not a software problem. If you are not able to decode, like for example here it's clearly mentioned it is on CPU 0 bank gate where the issue happens. Okay, so you can spoke to your hardware vendor like this is a error we are seeing, or even your hardware diagnostic utility which is provided by your hardware vendor can help you to find it out like where exactly the issue is. Okay, so it is generally starting from rel 6 it has been, they have demonized it. Earlier it has been run through your cron, sorry, chk config. Okay, and you will see file column MC. Okay, this is generated because this system is working fine without, and this is already a virtual machine, so generally don't see this kind of a issue over here, but this is how it works. Okay. Now let's look at the other stuff. So as I told you, we are still on the hardware part, like whatever the hardware error we have seen on a day-to-day basis. So modern processor supports something called a error detection correction, or popularly known as EDEC. So it is basically a hardware mechanism to detect and uh, report memory chip or memory controller failure. So you generally see this kind of a issue logs like in your verilog message like Northbridge error, node 1 core, this K8 ECC error. So Northbridge is basically been used to connect your processor to your memory or to your RAM. Okay, so like in a case of a MC or in a case of a MC check exception, MC machine check exception, you need to run the hardware diagnostic utility to find it out like what exactly is the error, or if you are not able to decode it, give it to your hardware vendor, or just run your utility like mem test or whatever you are provided by the hardware vendor to find out like where exactly is the issue. Same way you can do it with the error detection and correction, like run the diagnostic tool provided by the vendor or mem test. So it might be informational message, your EDAC message, such as a corrected ECC error like error checking and correction as printed in the system log. Or it might be a critical EDAC message, such as your exceeding hardware defined temperature threshold, which will trigger a kernel panic. So we can detect this error with the help of parity bits. I'm not going to go in much in depth of like the parity bits and in case of the issue how that is going to flip, and for that we have something called a Hamming code, not for error detection but also for the correction purpose. But just for sake of this demo, I'm going to tell you like you can use memtest or any of the hardware diagnostic utility to find out this kind of error. Now let's move to the other section called NMI or non-maskable interrupts. So before going to the non-maskable interrupt, I earlier created one of the presentation regarding interrupts and how is the IRQ balance going to distribute your interrupts between the different CPU. So non-maskable, I can say it is special kind of an interrupt, and like in most of the case, like interrupts are either your software based or a hardware based. NMI can be received from the same way that the NMI can be received from the various sources, but mostly, but the most common source is your hardware generated interrupts. And whenever the NMI is received, it is simply cannot be ignored by a processor because it's mostly being generated by your generally regarding your hardware error, which cannot be ignored. So it might be your problem with your memory. It might be a problem with your something. Somebody has pressed the system reset button. So this kind of error cannot be ignored. So this is one of the most common error which has been seen by many of the people, like kernel dazed and confused but trying to continue. Kernel 2 have a strange power saying mode enabled and who NMI receive for unknown reason 21 on CPU 0. So the kernel has a mechanism to handle this certain known NMI which has been coded inside your kernel, but unknown ones typically result in kernel log warning messages such as this because kernel doesn't know what to do with this particular NMI. Okay, so these unknown NMI message can be produced by your error check, correction, ECC, and other hardware problem. So in case if you want to generate a vmcore out of it, you need to enable a one parameter unknown, this one. So whenever the kernel receives this unknown NMI, it is going to panic and generate a vmcore for you. Okay. So a little bit introduction to your NMI watchdog. So at software level, we have a NMI watchdog that will trigger an NMI from software when a certain condition is met. So let's see like what are those conditions are met. So whenever the NMI watchdog facility is enabled in your in kernel, whenever the NMI watchdog facility is enabled in kernel, built-in kernel deadlock detector, and is used to detect hard kernel locks by executing periodic interrupt to see any CPU is logged and print out the debugging message. So whenever your NMI watchdog is enabled, it keep on monitoring like any of the kernel deadlock, means it act as a, like I said, is a watchdog which check like if there is any if any of your CPU is logged and print out the message. So generally you need to enable this parameter grub dot inside your grub.conf, and you need to add the entry like this. Okay, need to add NMI, okay, underscore watchdog equal to 1 to enable this. And once it has been enabled, you can check in your proc interrupt, reboot your system, check in your proc interrupt, it should be enabled, and your NMI should be enabled. Okay. Even after enabling this parameter in your grub.conf, you will still see this as a 000 like we are showing here. That means your system or your hardware doesn't support this. Okay. And in like this a virtual machine, and in case of your virtual machine, if you still see these messages regarding the NMI days and confused, you can simply disable it by putting that value equal to 0. Okay. So before winding up about the NMI, one thing I want to tell you, like OS does not have a much role to play in case of your NMI handling. So what the task of OS is primarily report whatever the hardware throws to it. Okay. So the kernel is able to interpret the reason for some NMI, and the normal behavior is to log it and attempt to continue whenever this NMI interrupt happen, is to continue the normal operation. So whenever you see these kind of a messages or NMI, the best thing you can do is to contact your hardware vendor. to they are best person to decode it for you, like because like I mentioned earlier, some of the NMIs they have been coded inside your kernel, so the kernel will be able to interpret it. But in case if it not, it will means give you these kind of messages received from unknown reasons. So kernel don't know what to do with these kind of NMIs. Okay. So this is a little bit introduction about whatever the general issues we have faced in our day-to-day life regarding from software point of view, the software kernel panic or hung or crash, and same way in case of a hardware point of view, like how can we configure MC logs and different parameters so that you can generate a VM core and find out what exactly happening in your system at the time of a crash. In the next video, I'm going to demonstrate you how to configure your kdump along with the your sysrq keys, the magical sysrq keys, and how can you generate a VM core out of it. And in the last section, I'm going to demonstrate how to read that VM core, some of the basic command. So thanks for watching this video. In case of any query and question, you can write it to me at laprashant@gmail.com. Thanks once again.